Today on the Creative Society channel, we welcome Randall Carlson. Many of you know him. Randall is known as an explorer and scholar and has over a 40-year-long career as a researcher. He is the host of the Cosmographia podcast, producer, and author of books. His research includes dozens of fields such as astronomy, earth science, paleontology, symbolism, and many more. Randall, welcome. We're so happy to have you with us here today. Please tell our viewers, what are you up to right now?
Well, right now, within the last 6 months, I built this studio that I'm in. It's a sort of a deluxe, almost state-of-the-art podcast studio. So I've affiliated with howtube.com, which is an internet platform dedicated to free speech and, unfettered dialogue and discussion and debate. So I've been working with them for 3 years now, and I was the initial flagship content creator. We've grown to over 100 now and adding more content creators every week. So anyways, that's one of the things. And then, continuing my geological researches, we're going to be exploring some of the unique geology of Eastern Kentucky, which is one of the things very few people are really aware of what's hiding under those forested landscapes. There's some amazing stuff. It's one of the most concentrated areas of natural bridges and rock arches in the entire U.S. And there's a very interesting possible explanation for how those natural bridges and rock arches come to be, how they form, because we don't really see them forming today. What we see today is the remnant rock arches and so on are slowly decaying away, slowly eroding away. We do not see examples of them forming, which leads to a conclusion that they formed under circumstances different than the environment that we're experiencing today. I'm about to be launching a class, you could say, a course on the principles of sacred geometry. It's going to utilize the principles that you would have been incorporated in, say, classical Greece, using a straight edge and a compass, an unmarked straight edge and a compass, to do all of the essential drawings. So then the longer term thing that I'm really working on and excited about, and there's a sort of a core group of folks that are coming together around this idea, is in my spare time in years past, I organized classes both for adults and for kids that were being homeschooled. And by doing this for, decades, I've come to certain insights and understandings of education. And so I've thought, the two things that I have done primarily in this lifetime to earn my keep is building and teaching. So it just seemed logical and natural to me that how you would bring those two things together would be to build a school. So I'm affiliating with a group of people that I've been in business with and friends and things, and we're looking at properties, mostly right now in Eastern Tennessee, as a potential place to lay down the cornerstone and build a school. I've been teaching things online, and as valuable as I believe, using the technology and the digital realm to teach and reach out and connect with people, it is not a substitute for what happens when you have a group of people meeting in person. That and we don't want to lose that.
Seems like you have a lot on your plate, but at the very same time, we can see how much passionate you are about everything you do. Of course, congratulations on having this beautiful podcast studio. We've seen your recent podcasts, and you know what?
Thank you.
What was very interesting for me personally, that the topics you're touching upon is the very same topics we've been disclosing at our international online conferences, Global Crisis, and everything you talk about, it seems like absolutely different spheres of research, from geology to energy to history. But when we were looking for evidence of the Great Flood, historically, we found over 150 different separated nations around the world who have it in their history. Not just the Great Biblical Flood, but every single continent, every tribe, every nation, they had their mythology around that event, that something really, really serious happened back then.
Well, you bring up the flood myths, and that is something that intrigued me. That was early on. That was some of the things that really intrigued me, as I was young, really just out of high school reading. I was obsessed with mythology. And so I kept seeing over and over again the stories of the floods. And that was when I started thinking, there's probably more to this than I was raised, we were kind of an agnostic household, but I was still familiar with Bible stories. And so I was very well familiar with the story of Noah's flood and all of that. I didn't know that, it had its counterpart in Sumerian traditions and Chaldean traditions and even, Native American traditions until later on I learned that. And then I go, well, what's the standard explanation? Well, the standard explanation is that you have, a devastating regional flood, but it's not anything really so far out of the range of what we've experienced in modern times. That there was flooding in the Tigris-Euphrates Valley. And then through the telling, of the story of this flood, it got exaggerated over time. That was pretty much the standard explanation. So over generations, the story of this flood got exaggerated. Well, one of the things that I'm doing is, these tours that I do, I teach people the principles of paleohydrology, which is the study of ancient water flows. So I use, in order to understand that, I explain to people that the effects of water erosion and sedimentation and deposition are scale invariant. So that what that means is that the work that water does, say erosional and depositional, and the types of forms that it creates are pretty much consistent, whether you're looking on a very small scale, like, on the side of a small creek, or all the way up to mega flood events. And so, in fact, I didn't pull it up, wasn't ready to show that today, but I have a presentation I've done just on showing this scale invariant relationship between microscale phenomena, human scale phenomena, and then macro scale phenomena. And you see that typically in geological textbooks and in articles and things, there will be a photograph of some geological formation. And invariably, there will be something put in that photograph so that you understand the scale that you're looking at. Because you might look at a photograph of a geological outcrop, and you're looking at it and you're going, well, am I seeing something that's inches high, a foot high, or is it hundreds of feet high? And so what'll happen is usually there will be a rock hammer or a hat or a person standing in the picture, so you get the sense of scale. Because geology, like certain realms of mathematics, fractal mathematics and so on, is scale invariant. So what I do is I show examples. I take people out to like local creeks and things. We look at an event, say after a particularly heavy rainfall. We'll look at a sandbar and we'll see certain kinds of patterns and forms and shapes on there. Then when we're out in the field, you see the thing is when you're looking at megascale phenomena, it's so vast and so huge that you don't really see it from the ground. You don't understand the scale and magnitude of the hill that's in front of you or how that hill got there. So that's how I do it. And so I bring people out and I show them features in the landscape that were created by flows that are only measured in hundreds of millions of cubic feet per second. Now, you say that to somebody who has not got the conceptual framework, what does that even mean? Well, I use analogies again. In America, back in 1993, the Mississippi River had a tremendous flood. It was the second largest flood of the Mississippi River since in the 20th century. The previous year was 1927. In both cases, the peak discharge, and at 93, when this Mississippi flood happened, it was the most costly economic disaster in American history at that time. That flood peaked out at just over 1 million cubic feet per second, right? I'm bringing people out into some of the western states, and we're traversing terrains that were carved in a matter of weeks by flows that may have exceeded that by 700 times to 800 times. So you can't even begin to get your head around this until you've spent a week traversing these landscapes. So what I do is I use a combination of, aerial photography, drone footage, satellite photography, topographic maps, and then lots of field excursions so people can get the picture. Because you can show slides all day of these features, and it just doesn't really, it just doesn't gel in your mind what you're looking at until you're out there in the field. And then you're seeing, wow, we're standing here in a canyon that's 1,000 feet deep, a mile wide, and you're telling me that this was carved out in perhaps a week or two? And the answer is yes. So here's what I'm getting at. Circling back to the idea of myths, if you have a flood that's 500 million cubic feet per second, you're talking about a flood that could completely wipe out thousands of square miles of landscapes, pre-existing land, and everything that was there. Now, if you have people that by whatever means, either because they planned for it or just by the luck of the draw, they survived, in many cases, there was a paucity of witnesses simply because the events we're talking about were so extreme that people who were there to witness it didn't survive. But in some cases, they clearly did. In some, idiosyncratic situations, they survived in order to tell the tale. Well, what would happen? Like one of the great meltwater flows coming off of the ice sheet at the end of the last ice age, both just before and after the Younger Dryas period, which lasted from roughly 12,900 to 11,600 years ago. Those floods came down and they were augmented beyond the current flow of Mississippi by hundreds of times. If you look at Google Earth or Google Maps, you can actually see that the flow, when you get to the southern states, was 100 miles wide. In fact, if you look at a map, you can pull up Google Maps, and go to terrain view, go to satellite view rather. You look at the city of Memphis, which is western Tennessee, and the city of Little Rock. They're separated by 100 miles. They're both on bluffs, and those bluffs were the banks of this ancient, gigantic meltwater river. Now, if you were a witness and you were on one of those bluffs looking out, all you would see, as far as the eye could see, would be a sea of mud with thousands of icebergs stranded in it. And as far as you could tell, the whole world that you knew before this event was gone. And you would have no basis to judge what might remain in other parts of the continent or other parts of the world. And for all you know, your world had been destroyed. So anything that you pass on, it takes on that form of total world destruction. So that's how we have to understand it in a scientific sense. The believers in floods, giant like the biblical flood, assumed that it was supernatural, that the waters rose above the highest mountains and then supernaturally disappeared. Now, the scientific community has rejected that model simply because it's unscientific. There's no evidence to explain where the water would come from, where it would go. But we have several mechanisms now to generate gigantic floods. One, rapidly melting ice sheets, which definitely happened at the end of the last ice age. Pulses of meltwater discharging off the ice sheets, rapidly entering the ocean basins, causing a rapidly accelerated sea level rise. And the other mechanism for generating gigantic floods would be tsunamis, the kind of tsunamis that could result from bolide or asteroid impacts into the oceans. And we know that asteroid impacts are far more common on this planet than people imagined a generation or two ago. We also know that the land area where we're doing most of our crater counting is like only a quarter of the surface of the Earth. So we've identified roughly 200 craters now on land, right? And there's probably far more that are going to be discovered before we're done with this thing. Well, you can figure you're going to have at least 3 times as many impacts into oceans as you've got on the land. So if you have an oceanic impact, say a half a kilometer object is moving at 15 or 20,000 miles per hour, slams into the ocean, it is going to create tsunamis, which at landfall could be hundreds of feet high. So there's your other mechanism for generating these gigantic floods. I lean towards the direction that the biblical flood was a tsunami flood coming up from the Indian Ocean. And if you look at the topography, you'll see that the Indian Ocean converges into the Arabian Sea, and that's exactly the kind of configuration you would need for the tsunami wave to build up, and attain incredible heights by the time it reached landfall. And there is some evidence that there was a bolide impact into the Indian Ocean around 7,000 years ago. So I am not of the mind that all of the flood stories necessarily refer to the same flood. In fact, I think what the record shows is that gigantic floods, mega-scale floods, are far more common than anybody had assumed before, a generation ago. And as a result of that, there are many cultures that have preserved stories of gigantic floods, but they're not all necessarily the same flood, because we now have evidence in hand, theoretically, how we could generate gigantic floods of that scale, and empirical data suggesting that there have been multiple scale events. For example, at the end of the last ice age, studies of sea level rise have shown at least two really vastly accelerated periods of sea level rise called meltwater pulse 1A and meltwater pulse 1B. Meltwater pulse 1A is dated at 14,500 years ago. Meltwater pulse 1B is dated 11,600 years ago, which was precisely the end of the Younger Dryas. And interestingly, it's precisely the date that Plato gave for the seismic destruction and subsidence of Atlantis into the Atlantic Ocean, precisely the same date. To me, that's not coincidental. To me, that actually confirms the possibility that Plato was reporting a historically authentic tradition that he had received. Otherwise, we assume that this huge meltwater pulse into the global oceans being precisely timed with Plato's chronology is just a coincidence. But I don't necessarily think that. So I think that there's evidence emerging that right at the Younger Dryas itself, there was a third meltwater event, actually dating, I think, to around now 12,850 years ago. And usually it's interpreted as the catastrophic draining of Lake Agassiz. Now, have you ever heard of Lake Agassiz? Lake Agassiz was a gigantic meltwater lake that it was assumed formed over a couple of thousand years of glacial melting. The evidence that I'm looking at now suggests that perhaps it was not created over several thousand years, but much, much more rapid than that, and was probably or could have been the result of a multiple impact event over the northern hemisphere that included impacts into the ice sheet itself. Because some of these meltwater flows are impossible to explain by conventional means. You have to look at some source of energy that could cause the transformation of huge masses of ice into large volumes of water. And I think that the two most likely possibilities are, number one, impacts of asteroids and or the debris of comets, and two, possibly a role for the sun. I think that the sun likely plays a role as well. And in fact, it could be what we're learning from satellite observations over the last couple of decades of the sun is that when you have bolide impacts into the sun, there's a whole family of comets called the Kreutz sun grazers that we didn't even know existed. And there's dozens and dozens of them, and they fall into the sun on a regular basis. There's some statistical data that would suggest there might be a correlation of the infall of cometary masses into the solar chromosphere and the ejection of in the formation of coronal mass ejections and solar storms. If that turns out to be viable, we may have a mechanism here whereby we're looking at phenomena that's not just terrestrial, but might involve the whole solar system itself.
When we talked with you before, we were talking about some kind of, intergalactic, maybe possible radiation or something that's affecting the core as well. But we see that there are changes that happen every 12,000 years on the planet. Have you noticed that as well?
Yeah, the frequency I've looked at is closer to 13,000 years, but really, since we're dealing with nature, I don't think we can look at a really precise timetable. We have these cycles. We have cosmic seasons that I think are characterized by glacial ages and interglacial ages. One cycle, it may be 12,000 years. The next might be 12,500. The next might be 13,000. What we need is a long term, like over hundreds of thousands of years of statistics in order to see what the precise timetable is that we could take as an average. But yeah, 12,000 to 13,000 years, in that range, it seems to me, because when we go to 25 or 26,000 years ago, there was a major climate shift that led from what was glaciologists would call an interstadial, which is where the ice disappears, but not all the way. We're in an interglacial now, and this is the prototype for an interglacial, what we're at now. If we go back 20,000 years, that was the late glacial maximum, and you basically had more than double the amount of glacial ice on the planet that there is now. Now, if we establish these as the two endpoints of this continuum, interglacial, like now, with sea levels more or less at this level, a full glacial, which means you're talking about somewhere around 6 or 7 million cubic miles of ice piled up on the continents, with a associated lowering of sea level by maybe 400 feet. If you look at those are the two endpoints, but within that, there are lesser intense changes that have terminology. It's a stade, or a stadial, which is a period of global cooling, which causes glaciers to expand, but not to the same extent that we saw 20,000 years ago. We might be talking about a lowering of sea level of 100 to 200 feet, for example. And then an interstadial is a warming where most of the glaciers melt away, but it's still not as warm as it is today. So if you can picture what I'm describing, the extremities, the extremes are glacial, interglacial, and then the lesser extremes are stadial and interstadial. So what we see is that around 25 to 26,000 years ago, the planet was in an interstadial period. Now, some studies suggest that it was close to being an interglacial, that sea levels rose almost to the height that they're at now. Glaciers of the whole 100,000-year-long Wisconsin ice age shrank. They didn't completely disappear, but they shrank considerably. This is the setting now going from 25 to 30,000, 35,000 years ago. In fact, there were extensive forests growing in Canada where 5 and 10,000 years later, it was buried under ice, right? So now around 25 to 26,000 years ago, there was a major climatic shift. And that was the beginning of what is now called the late Wisconsin phase of the Ice Age. So the Great Ice Age had this final phase. It seemed to be inaugurated right there around that period of 25,000 years ago. And then over the next 5,000 years, the glaciers grew rapidly, sea level lowered rapidly, and by 18 to 20,000 years ago, we were in the LGM, or late glacial maximum, and there was now somewhere between 6 and 7 million cubic miles of ice piled up over North America and Northwestern Europe. And to this day, we don't really have a clear explanation of what exactly happened. Well, now imagine this. Imagine that all of a sudden, next fall, there's a climate shift, and spring does not come back into the world for 10 or 12,000 years. That's essentially what happened at the beginning of the Ice Age. And it was that fast. It was so fast that it was the shift in climate. Now, obviously, there's going to be a huge lag period between the shift in climate that allows the accumulation of the glacial ice. That's going to be much faster than the accumulation itself. Let's say the accumulation takes 3,000 to 5,000 years. Well, that doesn't mean that the climate shift was 3,000 to 5,000 years. The climate shift is essentially instantaneous, and the subsequent buildup of ice sheets is then what happens. But here's the conundrum that we have to deal with when looking at the onset of an ice age. It has to be cold enough that the ice doesn't melt, right? And you cannot have the formation of huge swaths. I mean, there was 6 million square miles of land in North America buried under ice. There was at least 1 million to 2 million buried under ice in Northwestern Europe. So that means that, at least in terms of the Northern Hemisphere, it had to be cold, right? Well, and we know now also that there was buildup of ice even as far south as Tierra del Fuego. There was an expansion of ice in Antarctica. There was expansion of ice in the New Zealand Alps. It shows us that the ice age climate was global. Well, now here's the problem. To get that precipitation, you have to introduce water, moisture, into the atmosphere. But to do that, it requires heat. Now, if you start cooling off the planet, what happens to rates of evaporation? They decline in a major way. So this is the paradox that we haven't figured out yet. How do you get that much water into the atmosphere that can then rain out over millions of square miles of the Northern Hemisphere landmass? But at the same time, it's cold enough that waterfalls of snowfall turns to glacial ice and remains frozen for the next 10 to 15,000 years. There's the issue right there. And nobody's come up with a solution that I've seen.
And nobody's even trying, and because it's a very, somehow this became a very politicized topic, because now we're at the moment of our history where it became a very profitable business to spend trillions of dollars on trying to prevent our temperature from going 1.5 degrees up. But according to what you're saying, there was a major shift up to 18 degrees Celsius very fast, right?
Are we seeing this undulating graph?
Yes.
Okay, so this is an older graph times 1,000 years. So this is the present over here on the left, and this is 400,000 years ago. So what we're seeing here, the red line represents the present temperature. And you can see that over the last 400,000 years, during which the planet has spent most of its time in the grip of an ice age or several variations of an ice age, the temperature has been colder than now. And then there have been these short periods of these peaks above the line where it's been interglacial warmth. And to the extent that these coincide with human society, these are times of prosperity. But what you'll notice here, though, to me, the most important thing is, again, we don't see precision like machine precision, but there's a very clear periodicity to these climate changes. Now, it may be longer between one set of peaks and another set of peaks, shorter, sometimes longer than others. But that's what I was referring to earlier, is that there is a tempo that apparently has a periodicity to it. And that tempo, I think if we had enough data over long enough period of time, we'd be able to discern what a sort of a precise measurement of those changes are chronologically.
When this peaks, how much time? Because I'm seeing there is a timeline multiplies 1,000 years ago. What do we see in here? Is it 17,000 years ago and then 13?
I'm sorry. Okay, so it's 0 on the left and 400,000 years on the right. These are actually these numbers represent glacial stages. They're called. Mm-hmm. So that's all these numbers are. The 1 through 17, these are glacial stages. If you go into the literature of glaciology, they will talk about a specific, glacial stage that might have occurred 250,000 years ago, glacial stage 11, right? And then they're looking to correlate other things, sea levels, changes in the biosphere, changes in the global temperature, those kinds of things. This data is taken from the Caribbean. It's the study of sea surface temperatures. And how that can be determined is by looking at what kind of creatures live in the ocean, live in the sea, because there are very distinct types of life forms that live in warm waters as compared to what lives in cold waters. So if you see a turnover of warm-loving species suddenly replaced by cold-loving species, well, that tells you something about the temperature of the water. All right, are you seeing this graph right here?
Yes.
Okay, so let me explain what's going on here. The right-hand side is years. The top is the present. And if we go down here, you see the 10, that's 10,000 years ago. And this is Greenland isotopes. This is one of the most accurate and dramatic replications of ancient temperature changes. To the left, these squiggly line as it shifts to the left means the climate is getting colder. Shifting to the right means it's getting warmer. The number on the left here is the depth of the ice core. So by coring down 1,500 meters, we're at 10,000 years ago. What we can see from this graph is that the temperature has not been stable. The amplitude of these shifts back and forth is between 1 and 3 degrees. This is the Holocene, right? The last 10,000 years is the Holocene, the most recent geological epoch. And what that means is when you look at this graph, at least over the northern hemisphere, there's no point at where we can say, okay, there the climate is stable for X number of years, for centuries or thousands of years. It's just not there. It's showing, like if we go down here to this you see this little spike coming off to the left, that represents a 3 to 4 degree cooling spike that lasted for a couple of centuries around 8,300 years ago. Now, if that cooling spike happened now, we'd be in a world of hurt, because what we would see would be multiple years of agricultural failure. We would then see food shortages. We would see people dying from the cold. We would see people becoming malnourished. When the people become malnourished, at that point, then their immune systems get weakened, and that's when opportunistic diseases can occur. We saw exactly this happen with the onset of the Dark Ages cold period, which actually happened within 1 year from 536 AD to 542 AD or 546 AD. There was a period of about a decade where the dendrochronologists have been able to document that forest growth in the northern hemisphere almost came to a virtual stop. The year 536 AD is considered to be possibly the coldest year of the last 2,000 years. So what you had there was a period of about 10 years where basically it brought the final end of the Roman Empire and plunged Europe into the so-called Dark Ages. And now, while Dark Ages is oftentimes considered a metaphor, there was a literal truth to it, in that we know from records from monasteries and so on that there were periods of relative darkness where the sun was not seen for weeks at a time, most likely attributed to spasms of volcanism. And we know that the effects from modern times of what concentrated volcanic events can happen when between 1809 and 1815, there were at least 4 closely spaced explosive volcanic eruptions, which led to a mass of particulate matter in the atmosphere that reduced available sunlight, and in 1816 has been referred to as the year without a summer. It has also been described by historians as the last great subsistence crisis of Western civilization. And it literally was snowing, in New England. They were having a 4th of July celebration, and it was snowing out. So what happened was, because of the cold weather, spasms of cold weather over that summer it killed the crops, which caused people to go hungry. Well, back up to 542 AD, and after 6 years of cold weather and crop failures, you had the Justinian plague that wiped out half the population of Europe. Fast forward to around 1340, and you had the onset of the first phase of the Little Ice Age, as it's called, subsequent to 3,000 years of the medieval warm period, which was a period of prosperity. So within a few years or a few decades, and it wasn't uniform in every place, but over a period of a few decades, the global climate cooled by a couple of degrees. As a result, there were again crop failures led by famine, followed by the bubonic plague that came along in the year, I think 1342 maybe was the year. And then that pretty much wiped out huge swaths of the population of Europe. It brought to a rapid conclusion, a rapid end, the great grand cathedral building era of the High Middle Ages. It brought about, a collapse of the population of Europe, a decrease in lifespan, an increase in infant mortality. And that Little Ice Age, which was essentially in two phases, separated by the period we know as the Renaissance, that Little Ice Age only really came to an end around the mid-19th century, which is interesting because that's an important point. Our baseline for judging how much modern climate has warmed, the baseline is the Little Ice Age, which was the coldest century of the entire Holocene, and during which glaciers grew to their greatest mass in over 10,000 years globally. So when we're looking now at modern glacier recession, it's important to keep in mind that we're looking at a recessional process that began when those glaciers were the biggest they had been in 10,000 years. And likewise, when the climate had been colder than it had been in 10,000 years. And this is a fact, and it's completely ignored. So let's go back to this graph that's right here. This is the Holocene. Now, the whole graph, which is a result of an analysis of Greenland ice cores that were extracted between 1988 and 1993, right? When you pull up these ice cores, they have layered ice that very much like tree rings. You can analyze these layers of ice because each year you have this annual deposition of ice, and it incorporates oxygen isotopes, soot, dust, pollen, and all of that stuff can be analyzed to infer information and insight into the prevailing climate at the time. Like if a lot of soot shows up, you know that there were fires. If a lot of dust shows up, oftentimes a dust layer will show up subsequent to a soot layer. Well, what that tells you is you had massive fires that burned off the vegetation, exposed the surface soil. Winds came in and picked up that surface soil, and then that was lofted over and deposited on top of the ice sheet. Okay, so the cores went down to the base of the Greenland ice sheet, right? They've been analyzed now for several decades. And what we saw was quite shocking, and you'll see it in a minute. Interestingly, what you're about to see has been completely ignored in all of the discussions about climate change, anthropogenic climate change. And in fact, the stuff that I was just talking about, the fact that the Little Ice Age period, which coincided, interestingly, with the dawn of the Industrial Revolution, you had the Industrial Revolution beginning as the Little Ice Age was ending. So there's virtually no discussion about the fact of the Little Ice Age and what that implies in terms of our modern statistical data analysis. But here's the other thing that's ignored. We're going to go back 10,000 years, and then what I'm going to do now is I'm going to show you the rest of the graph back to 250,000 years ago. Now remember, these oscillations here vary between 1 and 3 degrees. So in some cases, these oscillations are greater than the warming, the measured warming of the last century and a half. Okay, so here we go.
Oh, wow. Take a look at that. So it's far not the warmest period of our history, it turns out to be, right?
Now, how come this is not part of the discussion?
Because it's a very uncomfortable part of the discussion. It's supposed to be straight as a hockey stick, shift.
Yes. You want to talk about global warming? Look at this down here. This is called the Eemian. And look at this. Now we're talking about climate shifts that happen in a geological instant. Literally less than a decade, possibly less than 5 years, even possibly as quick as 1 or 2 years. And we're not talking about that. See, here's what happened. When this kind of data started coming to the forefront and we started looking at it, what's happening simultaneous with that is the contrivance of the whole global warming scenario. The conversation about natural climate change, catastrophic natural climate change, got pushed off the table, and what came to dominate the discussion was focused 100% on the human influence on climate, to the neglect of what you see right here. That's what happened. So politics intervened and has dominated the discussion since then, because you can talk to all kinds of people who, the climate crisis. I can tell you, I'm going to guess Greta Thunberg has not seen this graph. You know what I'm getting at? I mean, lots of people are well aware of the fact that there are, storms and fires and droughts and hurricanes. But what I've shown in depth on my podcast is looking at the real data, which shows that during times of global cooling, invariably, over and over again, we see that the episodes of major weather and climatic events are far more frequently associated with times of global cooling than of global warming.
And, you say that people are not talking about it. This is exactly the topics that we talk about. We precisely also showed these graphs and talked about the hidden data that is not shown to the public today. So that is very interesting that you're studying, of course, exactly the same thing.
I didn't know you were out there doing this work. So when I saw it, I'll admit it was exciting. I said, well, here's a whole group of people that are really looking at this data and looking at this stuff and coming to their own independent conclusions. So that made my day. I'll tell you, it did.
Just like you, we study everything. We have this multidisciplinary approach. We understand that everything is related. So
you're right. Everything is related. And to me, that's one of the big problems with modern science. And, there is getting much more emphasis on interdisciplinary studies, but really that's sort of the trend of 20th century scientific studies, is that it became ever more compartmentalized, and every branch of science developed its own nomenclature. And if you're outside, if you were not a glaciologist, you didn't necessarily know what the terms meant. Like I defined for you what we meant by stadial and interstadial, but I can tell you that most astronomers would not be able to tell you what the difference between a stadial and interstadial is. So that's part of the problem. So see, to me, what that means is there's a very important role for the generalist to come along at this point, a critically important role for somebody who is so oriented intellectually that they can integrate the disparate pieces into a coherent model of reality. And, many of the top scientists are, multilingual in that sense, but a lot of them aren't. They're so focused, and it's, you find that guilt, particularly like in archaeological and geological research, because, for example, in archaeological research, you might have an archaeologist that spends decades excavating one site, right? Well, nobody is going to know more about that one site than they are. Well, like in the recent, Ancient Apocalypse series that was Graham Hancock's docuseries that was on Netflix, it got a lot of flack, a lot of attacks. I know personally an archaeologist that focuses just on excavating sites that were sites of Civil War battles and things. And he knows a whole lot about the intricacies of, these battles and so on. But that doesn't necessarily qualify him to have an opinion about archaeological sites, in the pre-Younger Dryas, right? So but the way the whole thing was played was, well, if you're an archaeologist, it doesn't matter, if you've got a focus or a narrow limit or anything like that on your studies, your opinion on these matters of ancient history counts for a whole lot more, say, than Graham Hancock, who is a mere journalist, right? He is a scholar of exceptional attainment. And it's like when these people attack him, they just dismiss all of that. They say, well, the experts have said this and that. Well, okay, so you bring in an expert who might be an expert on one particular thing, but has never really studied the evidence for the Younger Dryas catastrophe, or what may have actually happened prior to that during the Bolling or the Alarod or the older Dryas, what might have been going on. Whereas Graham has spent, 35 years focused on this, right? He's gone to probably close to 100 countries. In his references alone, which aren't all of the papers he's included, he's probably read close to 1,000 papers on relevant subjects. He's interviewed dozens and dozens, probably hundreds of experts and specialists, ranging the full spectrum from bona fide, highly credentialed scientists in academia all the way out to fringe and everything in between. Now, his critics have done none of that. Yet what they do is they invoke, the experts, and I'm going to put finger quotes, experts have said, this is bunk, this is conspiracy theory, this is blah, blah. Well, then I'm thinking, wait a second, none of you guys have done any of that. Now, just the fact that one of them has a degree in archaeology and has spent 10 years excavating a site in Greece or wherever it might be, that doesn't make him an expert on these matters. Graham is the expert. He's the expert. You should be going to him with your questions about what went on, because he's looked into it more than anybody else. And to say, he has no credentials, right? Well, how is 35 years of studying this subject not credentialed? I've gotten the same thing. And people, Carlson, they'll usually say something, he's a building contractor, he has no credentials. And I've invited some of these people who've said this to come onto the podcast. Let's have a little debate. So far, no takers.
Well, now you know why you haven't heard about us before. Same thing, we are speaking the truth. We're showing it out there, but unfortunately, it's not getting out as fast as all the other false information that's out in the mass media.
Well, can I add, I know this is sort of, I guess, my forum, but I would like to learn more about your organization.
We have a lot of forums that we have, a lot of videos, a lot of research that we published. We will definitely share all that with you for you to look at. And maybe also we can come back to the 13,000 year cycle that you spoke of. And you talked about it a little bit. What are the facts that something happened at that time? What is some of the evidence that you have?
Well, if you look at the screen right here, I've pulled up, this is the spikes associated with that period of that 11,000 to 13,000 year ago period. And what you see here, I mentioned earlier, two meltwater pulses to the global ocean. They associate very closely with these spikes. Here's the one. This would be meltwater pulse 1A right here, dated at about 14,500 years ago. The Younger Dryas is right here. It's this drop right here. In fact, it may be this drop right here that spikes and then goes down to almost full glacial cold after the warming. Now, in climate change, there's something that's been recognized for really going back to the 19th century called the Milankovitch cycles. Milutin Milankovitch theorized that changes in the Earth-Sun geometric relationship, the changes in the eccentricity of the ellipse, the orbital tilt, the distance of perihelion, aphelion, could affect the amount of radiation reaching the surface of the Earth, right? Now, sometimes those forces will cancel each other out, but other times they'll amplify each other. And when they amplify each other, you'll get a very discernible warming or discernible cooling. However, those rates of change are very slow, right? Now, if you look at this graph, you'll see that from the cold depths of the ice age, like I said, late glacial maximum, here we are 20,000 years ago, we start coming up out of the ice age here. And if you follow this trend line, it would have continued right on up. And that what you're seeing is the Milutin-Milankovitch forces that are causing the global temperature to warm from the late glacial maximum of 20,000 years ago. However, midway through that process, you have this huge spasm, this double spiked spasm that interrupted the normal, slower, gradualistic climatic changes. And this was where meltwater pulse 1b. Then you had the plunge back into full glacial cold, and then you had a second meltwater pulse 11,600 years ago, and that's what finally kicked the Earth out of the grip of the ice age, and we can see that it continued warming up into the Holocene. So this is the area we're interested in. It's within this here that we see the rapid and sudden demise of the great ice age megafauna. So there was a mass extinction event here that essentially exterminated about half the top of the food chain globally. The number of species that disappeared was over 100 species of megafaunal mammals, meaning animals over about 40 kilograms or 100 pounds in body weight. And so within this frame of a couple of thousand years, over 100 species of animals that had been around often for hundreds of thousands of years, even millions of years. Mastodons had been around for millions of years. But they bit the dust along with all these other animals. So how do you explain that? Well, the up to this point, the attempt has been to explain the extinction by reference to Paleo-Indian hunters, which makes no sense at all, because that's a whole nother discussion we could have. It's a very interesting discussion. But the more you look into it, the less sense it makes, because for one thing, the estimates of human population during the late glacial maximum were 5 to 10 million. The estimates for just mammoths alone was 10 to 12 million. So how in the world are, and then you look at what percentage of a population of 5 to 10 million people are actually out there hunting, and why would they be hunting the most dangerous game on Earth? We know that they were hunter-gatherers and that they were hunting small game. They were fishing, and we can know from the archaeological sites what they were eating. And yes, sometimes they apparently were eating mammoth steaks, but not enough to eat 10 to 12 million mammoths to extinction in 1,000 years or so. That's just quite ludicrous, actually. So here's one of the Richard Fairbanks, who was involved in the analysis of these ice cores. He says here in an article that appeared in Nature in 1993, from measurements of annual ice layer thickness over the past 15,000 years, the authors find that Greenland's climate, emerging from the last ice age, twice shifted from glacial to interglacial conditions over an astonishingly quick 3 to 5 years. Now, imagine, we're talking those spikes, we're looking at 15 to 18 degrees Fahrenheit. Now, that would be a climate crisis. If we had a 15-degree warming or cooling within 3 to 5 years, what would happen if we had a 15-degree cooling that started 3 to 5 years ago? Where would our civilization be at right now? We would be pretty much on the verge of collapse by this point. So, but again, why is this not being talked about? Well, it's because this knowledge was eclipsed by the politics of global warming. Absolutely. And here, this graph shows the spikes of meltwater. There's meltwater pulse 1A, 1B into the global oceans. And the previous curve was a very smooth curve that reached a peak around 10 or 11,000 years ago and then tapered off. But the model that we now have is one of catastrophic sea level rise. This would have been the Younger Dryas right here, because this dip in sea level rise coincides with the rapid cooling of the Younger Dryas.
Randall, in your opinion, what could be causing these two spikes to happen so close in time and so rapidly? Like we can see that the changes are absolutely.
My thought, again, without having the full explanation for this, is that it's likely impact produced. I think in order to understand this, we have to go to a cosmic perspective. Are you seeing this slide of this dirt outcrop with this black layer?
Yes.
Mm-hmm.
That is the so-called black mat layer that separates the Pleistocene from the Holocene, and it is loaded with soot, amongst other things. But this black mat layer was known for decades, and one of the interesting things about it was that below that black mat layer, remnants of extinct megafauna had been found, but rarely, if ever, found above it. In fact, almost never were the extinct megafauna found above that black mat layer. Now, that black mat layer has now been identified on 4 continents. Now, the interesting thing is nobody really began to look at that, the composition of this black mat layer until the early 2000s. But once they started looking at it, what do you suppose they discovered? Well, they discovered abundant impact proxies, microspherules, magnetic grains, nanodiamonds, an iridium spike has been found, a platinum spike has been found. And that's what led to the idea that there had been an impact. The sudden Rancho La Brea termination at 10,900 plus or minus 50 BP, which has been adjusted since then, appears to have coincided with the sudden climatic shift from the Alarod warming to the Younger Dryas cooling. Recent evidence for extraterrestrial impact, although not yet compelling, needs further testing because a remarkable major perturbation occurred at 10,900 BP before present that needs to be explained. Now, those dates have been refined somewhat since then to 12,850 right in there. This is the paper that really started this whole firestorm of controversy, was this one by Richard B. Firestone, Alan West, James Kennett, and 23 others. Evidence for an extraterrestrial impact 12,900 years ago that contributed to the megafaunal extinctions and the Younger Dryas cooling. This paper ignited a firestorm of controversy that hasn't abated yet, although the critics have pretty much gone silent because what has happened in the last 5 to 10 years is that multiple independent teams have confirmed the existence of the impact proxies at precisely that horizon and have shown where the response of many of the critics has been substandard in its precision and its rigor in terms of determining the actual science. So this was the paper right here. A carbon-rich black layer dating to 12.9 thousand years ago has been previously identified at 50 Clovis Age sites across North America and appears contemporaneous with the abrupt onset of Younger Dryas cooling. The in situ bones of extinct Pleistocene megafauna, along with Clovis tool assemblages, occur below this black mat layer, but not within or above it. Do you know what the Clovis culture is? The Clovis were the people that were here, demonstrated to have been here in the centuries leading up to the Younger Dryas. And like the megafauna, they disappeared right at that Younger Dryas, lower Younger Dryas boundary that's demarcated by the black mat. So they rapidly disappeared, and little is known about them, but we're finding out more and more all the time.
Randall, there is an interesting question I have regarding what you've been shown right now. So,
okay, sure, go ahead.
At the very same time, about 12,900 years ago, we know that there was a geomagnetical excursion, Gutenberg. And this is very interesting that it fell fits into the very same period of time. And the very same time, we know, according to volcano map of those times around the world, there was a huge volcanic activity.
Yes.
And what could be causing all these things to be happening? Like, what's the explanation?
Well, here's my thoughts. There's a whole set of feedback processes that played out over several thousand years. Now, whatever the cause or the trigger for the rapid melting of the ice sheets, which I'm inclined to think was primarily a multi-impact event, one of the consequences of that is that you have this tremendous shifting of surface mass. I did a calculation, I don't remember what it was. It was hundreds of billions of trillions of tons of ice, the total ice sheet. We know that it had a profound effect on the geosphere because under the center of the Great Ice Sheet, which is now occupied by Hudson Bay, there's been a rebound of so far somewhere around 1,500 feet, which would be, roughly 500 meters. So when you have the weight of that ice, it's pressing down on the land and literally causing the lithosphere to subside by thousands of feet. Okay, so now you have this rapid melting of the ice, and so you have this redistribution of surface mass on a large scale that's occurring in a geological instant. The land begins to rebound under that has been now released from under the ice sheet. But when all of that weight is transferred back into the ocean basins, there's a corresponding subsidence. This is called isostatic compensation. So isostasy is the vertical movement of the Earth's crust, like plate tectonics is the lateral movement. Isostasy is the vertical movement. That vertical movement is primarily governed by changes in sea level and changes in continental ice mass. Now, when you shift that weight around, what do you think is happening down in the asthenosphere and in the lower lithosphere? It's being subjected to all kinds of stresses that are now, I think, responsible for causing not only a spasm of volcanism, but we know that there were huge earthquakes also associated with the deglaciation process. So my understanding of the scenario would be, and of course it's subject to, modification as we get more insight and more data, but my model would be this. You have an outside source, in this case, multi-bolide impact or multi-fragmentation of comet impact over the ice sheet. That causes rapid melting. That causes rapid redistribution of surface mass. That release of that tremendous weight then allows volcanism, which has been suppressed, to burst forth. It triggers seismic activity and so forth. So that is, and then another logical consequence of that would then be fluctuations in the geomagnetic field. Now, the other thing to keep in mind, there's a discipline called rheology that looks at the distribution of mass within the Earth's geoid. And you know that the geoid is not a perfect sphere. It's extended at the equator by 13-mile radius or 26-mile diameter, 26-mile greater at the equator than it is at the pole. Well, that acts as essentially like a great flywheel that keeps the planet more or less stable within its 23.5 degree tilt, because it allows the lunar gravitational field to act on that bulge, which is constantly trying to keep it locked in place. Well, what happens now, that the surface of the Earth varies by 13 miles. In other words, if you go from the equator to the North Pole, you're going downhill by 13 miles. Okay, so what happens if you release this weight and now large portions of the lithosphere are thousands of feet higher than they were? Well, what that implies to me then is that they're now out of equilibrium with their latitude. Does that make sense?
Yes, it absolutely makes sense. And Randall, here is it's incredible because you take into account such things as pressure of the actual ice on the our land on tectonic plates, things that are. We've been discussing this on our international online forums, and twice a year, 2 times a year, we create this extraordinary events on which we gather scientists from all different fields of research, and we even talk about the things that considered to be, well, not even taken into account. Like, for example, when we have a big megapolis with a huge downtown, skyscrapers, and so on, how much pressure it applies on tectonic plates, because it used to be considered that that way doesn't matter, that tectonic plates, they can handle anything. But right now we see that it matters. It makes a tremendous amount of pressure, and it changes a lot, and we can see it. But it's incredible because you mentioned the very same things, although because we have such a broad variety of scientists, and the very specifically the ones who study the inner processes inside of our planet, the missing part in our conversation today was the play of the inner core and outer core, because what was also noticed that during that period of time of 12,000 years ago, that magma that was erupting, it was enriched with rare earth materials, rare earth which is not common, which means it was coming from the very, very core, from the outer core. And right now in Hawaii, they find in this, substances that came from there. So something caused that. And what's actually very interesting that right now we're seeing similar kind of processes when we started seeing flows of extra hot magma, and it's a completely different substance. And then when we take in interviews with volcanologists, and they tell us about this, we notice that magma is much hotter. Magma has a different kind of substance.
Viscosity.
Not just that, but the materials, the components are different, and they don't know why. And then all of a sudden, we start noticing that there is a big amount of Marthquakes. So on Mars, they started having Marthquakes. All of a sudden, the core woke up, and in this area called Cerberus, they seen the huge magma plume rising up. So very similar thing that is happening on Earth right now, exactly at the very same time happening on Mars. And we're seeing the evidence that changes happening on other planets too. So we're like, whoa, must be some kind of external factor that, affects these things, which is not taken into account. And then last year when, the scientist from Canada, he dared to say that, cosmic radiation and cosmic rays and galaxy rays penetrate our atmosphere and destroying the layer, the ozone layer, on the equator, not at the pole, but at the equator. Right away, dozens of so-called experts started smearing him, saying that he made a mistake, he miscalculated somewhere. But there's no better person than that scientist from Waterloo University. And the question that we have here, because again, you asked the question, what are we talking about at our forums? What are we all about? Nobody's even paying attention to these things. That's why we're extremely pleased to have at our platform people who really think in broader, who can see facts and instead of rejecting them right away because it hurts their political agenda, careers, grants, and so on. Really take it into consideration, and hopefully, we are learning a lot from you today, and we really hope that you're gonna have a chance to watch our recent forum.
It's gratifying to me to know you guys are out there doing this. Because I'm totally committed to the idea that this is really important information. It needs to be out there more in the mainstream than it is. It needs to be discussed. It needs to be looked at not only by the lay public, but by the scientific community as well. Because there are many unanswered questions that I think have kind of been brushed under the rug. And these are questions that could have direct relevance to our long-term sustainability on this planet and our civilization. We've been talking about the evidence which is emerging from many different disciplines of science that we live on a really dynamic planet. It's part of apparently a much larger integrated system that encompasses the entire solar system and probably beyond. So I think that this is how we have to, this is really the framework of our thinking from this point on. We have to really expand the framework of our thinking to realize that, yeah, we could be looking at things that ultimately have a galactic level and then a solar system level, and then we get down to the individual planetary level. Because clearly in my mind, we can't be looking at what's happened on Earth without looking at the larger picture. And of course, all of that is bound to the sun, as is all of the planets. But it looks to me like the whole thing is working as a system, and that the parameters of that system, if you want to think of it as a kind of a celestial machine, if you will, are very precise. And if you start adjusting those in any direction, like move the Earth a little farther away from the sun or a little closer, or its mass gets a little bigger or a little smaller, it's kind of like the Goldilocks principle. When we begin to understand the architecture of our cosmic system of which we are a part, the cosmic ecosystem of which we are a part, we realize that the conditions are very, very precise. And if you start altering those conditions, even in the slightest, it can have enormous implications for the stability of life on Earth, in terms of evolution, all of these things. So I think that this is where we've got to go with our thinking. We have to start thinking integrally, and we have to start thinking cosmically to understand really what's happening, because I think what's ultimately playing out here on the surface of the Earth is the consequence of the confluence of a whole series of cosmic forces and interactions that includes all the planets, the sun, the cometary reservoirs in the far reaches of the solar system, and most likely things that are happening on a galactic level. So that's kind of my wrap up. Within that, there's a lot of details to study, a lot of interesting avenues to follow, pathways that lead to some pretty amazing things. I look at this as kind of like, I think of this as this knowledge as being like a great river. I used that analogy earlier, and sometimes it bifurcates and trifurcates into many channels, but ultimately they all flow back together again. I think we've been in a period where the great river of universal knowledge has kind of split into multiple branches, and now we're seeing the point where these separate streams are beginning to flow back together. And it's just awesome to be a part of it. And I want to live for another 100 years so I don't miss any of it.
Our whole team has been amazed by your energy, by your dedication, by how much projects you run in at the very same time and doing everything on a very, very good quality level. And I wish we had young people having that much passion about life, about the research, and about bringing this information to the society. It's like the most important thing each one of us can do right now, because information is the most essential thing. And yes, on frontier, you've been one of the leading people, and it's a great honor. I'm not exaggerating, for all of us to have you here with us.
It's an honor to me to meet you guys and to find out what you're doing, because every time I find out that there's something more like this going on, it increases my degree of optimism about our future. I mean, when I look at the political situation and what's going on in the world, I mean, it can be disconcerting. And I've watched what's happened in America. Say, I came of age during the Vietnam War, and I've watched what has happened in terms of, censorship and the suppression of ideas and the intolerance. And I'll say right out, I don't like it one bit. And I just think it's completely the wrong direction to be going. And it was manifested pretty dramatically in the response to Graham's recent Netflix series. And what my takeaway from it was I went through the attacks on him from journalistic sources, from archaeological sources and stuff. I mean, I maybe read like 8 or 10 different ones. What struck me was they were all working from the same script, even to the point where you saw some of the same phraseology. And when I began to see even sentence structure paralleling across some of these things, it became apparent to me that, okay, they've all got the same script. They've all got the same talking points. Where did that originate? That was my first question. You know, who's recruiting these people to come out and spin these fabrications and these lies? And they're not all independently coming up with this. That became abundantly apparent to me. So there are factions out there that want to keep, I think, the kinds of truths and realities and things that we're studying, who have an incentive to keep that out of the public discussion. And then that raises other questions that I think we need to address going forward, is what's their motive? Because in order to be able to come out with, you know, the alternative paradigm, which we desperately need, we're going to encounter obstruction. And I think obviously we have to stick to what we know and to what our truth is and just keep getting it out there. And I think in the end, my optimism is that truth is going to prevail. But it might not be that easy. You know, we may encounter obstacles, and we have to have strategies for overcoming those obstacles in a humane way. I don't know how we do that, but that's one of the things I would like to bring into the discussion over the next few months to next year. And that was really driven home to me when I saw this reaction to Graham, who's one of the sweetest people I know, you know, and for him to be subject to that kind of abuse and stuff just really, well, quite frankly, it pissed me off to see that. He didn't deserve that. He deserved a fair hearing. But, you know, here's the irony, is that all that bad press actually drove up the numbers of people watching. Yes. So maybe right there, you know, right there is at least a partial solution.
Yes, and you know, you speak about the solution of what we can do, and this is what we also talk about. We talk about the fact that right now we need to unite scientists. We need to unite the scientific potential. And we also talk about the fact, you know, in order to figure out what's going on with the world today, with the climate and the cycle and so on and so forth. But most importantly, we talk about what is this format of society that we want to live in. And I'm sure you noticed, and you said that you visited the Creative Society website, and there we describe what is this format in which we can all live, thrive? You know, what is this peaceful world? And we know that in the format that we live in today, and as Tari mentioned, this consumerist format, it's not possible to move forward. It is not possible to have any of the new technologies available to us. In order for that to happen, we need to change the format to the Creative Society, which is what we call it. It's not the name that's important. It's just the essence of what it stands for. And pretty much it stands for the fact that it is a format where human life is of the highest value, and where we have everything we need in order to live a peaceful life, a thriving life, and a prosperous life. And that's how every single person today should live. And through all the years of research we've done, we understand that it is possible today for every single person on this planet, even over 8 billion people, to live prosperously without any struggle, to have everything they need. And today we have the technology to for everyone. Thank you so much, Randall, for being with us today. Thank you so much for coming on the Creative Society channel. We really
You're welcome.
You.